Alright, so today's question is encode and decode strings. Look, this problem, it's much longer than the other ones that we've done. I think the examples are not very helpful, to be honest, but you know, let's just set that aside for now and just read the damn thing. Alright, so we have to design an algorithm to encode a list of strings into a string. Alright, we can see this. We're encoding a list of strings and we're gonna output a string. Very cool. And then that encoded string is then sent over the network and is decoded back to the original list of string. Okay, this is like a lot of text, but like effectively you'll have two functions, encode and decode. Encode is going to take in strs as the parameter, which is of type string array, and it's going to return a string. So for instance, you have hello world as the strs, and then you feed it into this encode function. The encode function is going to do some stuff, which is going to turn it into a string. I'm just going to call the string encoded, okay? And then this string is going to get sent over the network, and presumably there's going to be another machine with the decode function. And the decode function will take this encoded string and it's going to decode it and reconstruct the original list of string. So the problem here is, how do we take something like this and what code do we write to encode it such that once we send this string over to the decode, it can decode that back to the original form. Our responsibility is to implement both the encode and the decode function. So at the end of the day, to test whether this code works or not, there's going to be some test list of strings like this, which is going to be fed into encode. And then the output of encode is going to be sent to the decode function, and then the decode function is going to try to reconstruct a list of strings, and then the checker is going to check whether the decoded list here is equal to the original list. If it is, then we pass. If it doesn't, then we fail. It's pretty convoluted, but that's basically what this question is asking for. Now we can look into exploring some of the possible solutions. So let's start with the obvious solution. First of all, let's say we have this as our input. Now, if you want to turn this into a simple string, the easiest thing to do is to run the join function, which is going to look something like this. First, I'm going to specify what I'm joining it by. In here, I'm going to say just an empty space, dot join strs. And this is going to give us hello space world, like so. Very clean and simple. This can be our encode function. Now for a decode function, what do? Well, if the decode function receives the string and we want to separate them into elements of a list, then we can just run the split function. Dot split by, again, just an empty space. And this is going to give us, yeah, that seems to work, right? The original string seems to match the decoded string, all right? No problem. Seems like an easy solution. But it's not going to work in some edge cases. Now, imagine this. What if I change the input a little bit? What if I change it to hello space world as the first element? Ooh, we've got the space here inside a single element. And let's say we have a second element called foo. Now, if I try to encode it, what do I get? Just looking at this code, we're going to be joining all the elements with an empty space. So what do we get? Hello space world space foo. And now you might be able to see the problem here already. Let's say this is our encoded. Then I run split on our encoded. Encoded.split. That's going to give us hello world and foo. You see, because we separated them with a spacebar and then we rejoined them together later with a spacebar, now we get 3 different elements instead of 2 like this. Because of the delimiter that we've chosen, we actually don't know when an element starts and when an element ends, because we have that space inside our elements here. See? So we can't do this. So what do? If we cannot use space as our delimiter, what if we try a delimiter that won't appear here? A delimiter that's impossible to appear here. Well, lucky for us, if we look at this third point here, strs I, which is each individual string here, contains any possible characters out of the 256 valid ASCII characters. So we know there's a constraint. Not all possible characters can exist. Only ASCII characters can be used for each string. And well, unfortunately, the spacebar is actually part of the ASCII character set, which is why we can't use it as a delimiter. What if we chose a non-ASCII character? I'm gonna use a Japanese character, and this will definitely not appear in our elements, right? And because we know it won't appear, we won't run into this issue anymore. So what's gonna happen with this one? Well, when we run the encode function, it's gonna turn this, and we're gonna join it on this character, which will give us this. And when we split, the decode function will be able to do this correctly. It'll keep reading until we hit our delimiter, and then once it reaches that, it will conclude that this part is one element. And then it will continue reading again past the delimiter until the end of the string. And that's our second element. And look at that. We don't have that bug anymore. That's an easy fix. But unfortunately, my friends, it's not that easy. Because there's a follow-up to the question. There it is. Could you write a generalized algorithm to work on any set of characters? Uh-oh. This is not going to work then. If this algorithm is supposed to work with non-ASCII characters as well, then this approach is completely infeasible. Well, because of that, sadly, we have to bin this approach. Now, what if we flip our approach? Instead of having the decode function blindly read each character until the next delimiter, what if we could tell the decoder in advance how many characters the next string is going to be made out of? So instead of just reading until we hit a delimiter, I'm going to tell you somehow in advance how many characters to read. So it's more preemptive than reactive. Let's follow that line of thinking. Let's go back to our original example, hello world. What if we encoded it like this? We first put the length of the first element. Hello is 5 characters long, so I'm going to put at number 5, and then I'll put the string itself, and then I'll put the length of the second string, which is 5, and then I'll write the string itself. And this is our encoded. So what does decoder see when I pass this in? How do we decipher this? Well, given this string, if I know that the general structure of the string is going to be the length, followed by the string, followed by a length, followed by a string, and it just goes on repeating forever until we hit the end of the string, then we can write our code around that. So the plan to decode is to read the first character and expect it to be the length. It's like, I know this is the length. So 5, all right, cool, that's going to be our length. So I'm going to read the next 5 characters and see that that's my string. 1, 2, 3, 4, 5. This is our string. We add it to our results. Result, hello. And then once we finish that, I can expect that the next character is going to represent the length of the next word. So here 5. Again, then I take the next 5 and then I put it into my results. This approach works as well. It doesn't work too differently from before. It's just that we tell the decoder the length of the string in advance, instead of letting it read until it hits the delimiter. So that's well and good, but does it still work for the other test case? Let's try it on that. So the other test case we had was hello world, 1 element, well, 1 string, and the second element is foo. How long is this string? 5 characters, and 1 empty character in the middle. So 5 plus 1 plus 5, 11. 11, hello world, and as for this, we have 3, foo. This is going to be our encoded, same structure as before. Length, string, and we're going to pass it to our decode. Decode is going to receive it, and is going to run the same algorithm as before. So how do we do it before? The first character, we can assume this is going to be the length. So the length of the next string is 1. So that means I'm only going to read the next 1 character, and that's going to be our first element. Well, you can already see that this algorithm does not work. And then once that's done, it's going to assume that this character is going to have the length of the next string, which is not true because this algorithm didn't work properly. This is actually an alphabetical character, not a number. So the algorithm is going to crash, it's going to get confused, it's going to throw exceptions. So we can fix this. The problem is that the algorithm only assumes that the length is only 1 digit long, and in here it's 2 digits long. And if we check the constraints of how long a single string can be, we can see that a single string, there's I, can be as large as 200 characters, which means that the largest length is 200. So 3 digits. Okay, so this is a case that we definitely have to handle. Now, this might sound counterintuitive, but the trick here is to use a delimiter, but not in the way that we did initially. I'll show you. So the character that I'm going to use as the delimiter this time is a hashtag. So the new format, in order to support lengths that are multiple characters long, we're going to put a delimiter when we're done writing the length, and we can move on to the string portion. So here, we write that the length is 11, well, 1, 1 to be exact, and then we put a hash, and then we're going to put the string itself. Hello, space, world. And of course, we're going to do the same thing for foo. We're going to put the length of foo, 3, followed by a hash to indicate that we're done writing the length. And then the next part is going to be the string. So how does this fix our problem? What happens when we try to decode this? So decode will first do, I'll write the steps. The first step is to keep reading until we hit a delimiter. So it's just going to read character by character until we hit this. So here it stops after reading 2 characters. So once we hit this delimiter, we know that everything that came before it is going to be the length. 2 is going to be to record the length. So we're going to say that our string length is going to be 11. And since we know that the length is 11, from here, we can grab the next 11 characters and save it into our results. So from here, I'm going to grab the next 11 characters. 1, 2, 3, 4, 10, 11. So I'm going to grab this thing and I'm going to put it in my output. So that's step 3. Grab the next length characters. In this case, 11. And then once that's done, well, we can repeat from step 1 because we know that after that, there are 2 possibilities. First possibility is that there's going to be another set of length, followed by a length delimiter, followed by the string, or we're going to reach the end of the string. So in this case, we haven't reached the end of the string yet, so we repeat. So we read the number 3, and then we go to the next character, and oh, we've already hit the delimiter. Okay, so this time the length is only 1 character long, which is 3. Length is 3, and then after that, I'm going to grab the next 3 characters, 1, 2, 3, and I'm going to save that inside our dictionary. Sorry, I meant our list. And that's it. It's done. As you can see, our decoded answer is the same as our original input. And this works for all characters, ASCII and non-ASCII. But one question that I had thinking about this, why did the delimiter work this time when it didn't work initially? Well, if you think about it, it didn't work initially because initially, the only delimiter that worked is a character that we know for sure is not going to appear in the string. Once we've expanded the possible set of characters to encompass every character, well, there just aren't any delimiters that we can safely use anymore. But in this case, this hash delimiter that I chose will work because this is not a delimiter for the string. No, this is a delimiter for the length. And we know the length can only be numbers. I mean, it'll just be a number between 0 and 200, right? The character hash will never appear in here. It's just not possible. So because of that, we're able to use a delimiter that will 100% never appear in the set of characters. And in this case, the set of characters is just a bunch of numbers. So I guess the takeaway here is that we're allowed to use delimiters if we know for sure that it won't appear. Okay, now that we understand the general solution, let's try having a look at some code. We'll have to move this one sec. This is actually the steps for decoding, but encoding is different, and admittedly a lot simpler. So as we can see, initially our encoded is just empty. We're just initializing this. And then what we're saying is that for every string in strs, with the string 1 and string 2 here, we're going to append encoded. First, we're going to take the length of s, which in this case, in the first iteration of the for loop, is going to be this hello world. So we'll take the length of hello world, well, hello space world, which is going to be 11. We're going to convert that into a string, and then we're going to concatenate that with a delimiter, which I have defined up here. So I'm going to put a hash, and then I'm going to put the string itself. Oh, I didn't mention this, but there's no particular reason why hash has to be chosen, right? As we've established, so long as the delimiter is not a number, we're good. So you can pick whatever you want here. And once that's done, we move on to the next iteration. So for the second s, we're going to append to encoded once more with the length of s, which is 3. And we're going to add the delimiter, which is a hash. And we're going to add the string itself, which is foo. And that's it for the encoding, really. It's pretty simple. Now let's have a look at decode. So this encoded string is going to be sent to decode as its input. So here it goes. Bang, the string has arrived as the input. So here we're first defining our decoded, which is empty. I'm just going to get rid of the encoding code because we don't really need it anymore. So first we have decoded, which is empty, no problem. And then the next step, we initialize I to 0. So I is just going to be a variable that points to the index in the string. So I is going to start at 0 at first, and it's going to keep moving through the string until eventually it'll reach the end of the string, which is this condition here. So while I has not reached the end of the string yet, I want you to keep executing this code. So here comes the part where we use our checklist. Step 1. Keep reading until we hit a delimiter. Cool. So we have to find the delimiter. To accomplish this, while you could write a while loop, which will read the characters one by one, like you read the first character, and then you record that, and then you move the I to the next point, and then you record this, and then you move I to the next point, and then you go, that's the delimiter. This is going to be my length. You could write code like that, which will be a while loop. I just felt like having a while inside a while is not very pleasing to the eye. So I'm going to avoid it. And instead, I'm going to use our built-in Python function called index. I'm going to tell the index function to find the delimiter. Give me the index of the delimiter. Okay? Now, I also pass in a second variable, which is actually unnecessary for the first iteration, but you'll see this will be important later. So this basically represents where the index function should start looking. Anyways, I'll touch on this again later. First of all, the index function is going to return the index of the first delimiter that it finds. Okay? And in this case, it's going to return the index 2. So this is going to be saved in here. Okay? That's basically step 1 done. Step 2, we have to record the length. So I'm going to do an indexing operator. This is going to take all characters of S between the indexes I and J. Now, I at this point in time is 0, and J, wait, what the fuck is J? Wait, this code doesn't run. Bruh. Ignore the naming. Just imagine this is J. Just imagine this is J. Anyways, so as we know, J is going to be the index of the delimiter, and I want to take the substring between indexes I, which is 0, and J, which is 2. So I'm grabbing this. And by the way, in case you're unfamiliar with Python, the upper end is usually exclusive. So it's not inclusive of index 2. In practice, we're just grabbing the characters at 0 and 1. And then we can save that. Our length is equal to 11. Yeah. So that's step 1 done, step 2 done. And then step 3 is to grab the next length characters. Okay, so we want to grab the next 11 characters. So this thing. But before that, we have to skip the delimiter. Right now our eye is still pointing at this character. So we kind of want to shift it over here. We're going to shift I to one character after the delimiter. So we're going to put I here. H, that's what this does. J is the delimiter plus 1. And then we're going to extract the element itself. In other words, we're going to extract the string. So we know that the string is 11 characters. That's why we're indexing in between I, which is at 3 here, to 3 plus the length. Oh lord, the variable namings are all wrong here. I'm just gonna erase this. This is just supposed to be a length. Sorry fellas, a bit of scuff today. Anyways, we're grabbing the string in between indexes 3 and 3 plus 11. So 14. 14 is over here. So I'm going to grab every element in between 3 and 14. So like I said, the upper bound is non-inclusive. So I'm just going to yoink these. And that's going to be element. Oh, so I is 3 at this point. Sorry. And then once we have this, we simply append it into decoded. And then lastly, we're going to increment our I with not word length. It's just length, my friend. Variable names. We're going to increment it by length before, which is 11. So now I is going to be 3 plus 11, 14. So in practice, I is going to be moved to here. And then as you can see, that is step 1, 2, and 3. And then step 4, it's literally the same thing. We're doing the exact same thing as before. I'm just going to speed run this real quick. Now for the next iteration, we're going to run the index function on the S again. And remember, the index function returns the index of the first occurrence. So this is going to find the first instance of hash, which is going to be an index 2. But because we've added a second parameter, the behavior is modified. So this second parameter is basically saying, do the exact same thing, but I want you to find the first occurrence of hash after this index. So I right now is 14, which is here. So give me the first occurrence of the delimiter in here. Do not look for it here anymore, because I only want indexes that start from here. Pretty convenient, huh? So that'll give us this index, which is 15. So J here will be 15. 14 and 15 here. So, and then we grab the length. Length becomes 3. And then we're going to move I to J plus 1. I is going to be moved here at 16. I becomes 16. And then I'm just going to extract the element once again, which is going to go from I is 16 here to 16 plus length, which is 3. So 19 here, right? So 19 is actually here. So I want to take all of this, which is foo. And then we're going to say the element is now foo. And we simply append this. And then we increment I by the length. And the length was 3, I is 16, so I becomes 19. And then after that, we're going to go to the next iteration. But before that, we have to check this while loop. So the length of S is 19 characters. And our I has just reached 19. So is 19 smaller than 19? Nope. So this while loop will stop running, which means we've hit the end of the string. And now all we have to do is just return decoded. Pretty cool, huh? Let's run it. And there you go. There is one small optimization that I held off on, and that is to use generators and f-strings, or string formats, instead of just using string concatenation. We're concatenating the length of s with a delimiter, which was the hash before, and the string itself. And then once we concatenated all of this, we have to concatenate it with the existing encoded, which at first is an empty string. So in this one iteration alone, there's 1, 2, 3 concatenations happening, and then the next iteration, there will be another 3. So in order to explain what the optimization is, we have to go through why string concatenation is not the most efficient operation. So imagine that this is our strs once again. So when we run the first iteration, which will be on this element, it's going to take the length and convert it to a string, and then we're going to concatenate that with a delimiter. So the problem is, because strings are immutable, I can't simply append this hash into the string 11. And this is unlike a list where, let's say I have a list that looks like this, the character 1, another character 1, and then I append it with the hash. I can do this without needing to make a new list. It'll just get added to the end. But that's because lists are mutable. And because strings are not mutable, we can't just tack it on in the back. Python basically has to create a new structure and copy the 11 over, and then copy the hash over. And then there you go, that's the concatenation. And once we want to concatenate with the string, well, it has to do the same thing. It would have to copy the entirety of this and the entirety of this. And when I want to concatenate this with encoded, I have to copy all of this and then stick them together. You can see how this is getting very inefficient. And especially as encoded gets longer and longer, this is going to get worse and worse, since we have to copy each individual character over. So a more efficient way to do this is to be using f-strings. F-strings in Python are just called string formats, and it looks like this. You have an f, and then the quotation marks. Now if I get rid of this line, and then I put this line in here instead, it's going to be much better. Well, that's because Python will basically stitch all of these strings together without going through the whole inefficient copy and paste process that we mentioned earlier. I'm sure there's a lot of optimizations that actually go on under the hood as to how they make this happen, but all we have to know for Neetcode is that this is more time efficient than doing a string concatenation, especially if we have really long strings or like a lot of strings. However, if you're really anal, you'll notice that even with this optimization, we can't get rid of this one concatenation here for encoded. So it's not 100% there. Now, to get rid of that last concatenation, we can instead use lists. So you can see here, it's the same thing. Instead of using a string, we're using a list. And the reason is because we can use append instead of the plus equals, which is a minor optimization. And then we can just join them all together at the end. And the answer will be the same. And once we've built our list, we can use join to convert them into one big string. Well, if you're cracked, you can forgo the list entirely and just use the generator. Well, in practice, it's not that different, but it's cooler and it's a one-liner. So I'm gonna use that. I think my takeaway here is that I'm not saying that list concatenation is the devil or anything like that. Oftentimes, this is much easier to read and much easier to understand than this, because it's more intuitive. But I'm just introducing this concept because if you ever have to deal with like really long lists or like a lot of lists that you want to like join together, it's good to kind of get in the habit of using like f-strings, for example. But only if the performance matters, because I just think this doesn't look as good. This looks clean, it's a one-liner, but it's quite dense. And if you're working with other developers that's not as familiar with Python, then it's probably not a good idea to do something like this. But I just wanted to show you. Now let's calculate the time complexity. There's actually quite a lot going on in this encode, so I'm going to break it down step by step. First of all, this returns a generator object, and then this generator object gets passed into the join function. So if you try to print it, it'll just say generator object. Now the execution only happens once we run join. So what's going to happen? So first of all, create generator object, which is O1. because again, no execution has been done yet. Step 2, run the join. And now the generator awakens. For each string, the first thing it's going to do is construct the f string. Grabbing the length of s costs O of 1. Because if you want to get the length of a string, the length is actually stored as metadata, so Python doesn't go through each character one by one to count how long the length is. The length is already stored inside the string object. So that's O of 1, and then to write it is anywhere between 0 to 200. So aka in the best case, it's 1 character long. In the worst case, it's 3 characters long. So we'll take the worst case scenario, writing 3 characters, 1 character at a time. That's gonna just cost O3 at most. So O of 3. And then next here for the delimiter, reading the value of a variable is O of 1. And then writing just a single character is also O of 1. So overall, it's O of 1. I'm just gonna change the 3 to 1 because it's not gonna influence the final result anyways. And then here, writing the string itself. So the way that I'm gonna structure it is that, because our input is gonna be a list of string, like so, I'm gonna say that the length is n, and then the average string length is m. So the average length of each one of these strings is just gonna be m, and n is the number of strings. So basically, writing this down is gonna cost O of m. So to construct one of this, you basically just plus all of this, and the total cost, the dominating cost, is gonna be O of m to create one of this f string. So that's this step. Because the generator works at 1 iteration at a time, it's actually gonna send this f string over to Python or over to the join function where it's gonna store it internally, and then moves on to the next iteration. And then it'll do these 2 steps again until we've processed every single string. So repeat n times. So total cost is O of m times n, because we have to repeat this m operation n times. Now at this point, internally, we would have something like this. Now, we have to stitch these together. That's what the join function is gonna do. Well, then it's gonna block out a chunk of memory that's going to house the combined string. And we're gonna write in 1 character at a time from every part that we have so far. So I'm gonna call one of this a part, one of this a part. So we're just gonna write it all in, all at once into 1 big string. So the total cost of writing it is gonna be, how many strings do we have? Well, we have n strings, and then how long is each string? M. Well, technically m is like the length of this part, but this thing is so small. This thing only goes up to like 4 characters at most anyways. I'm just gonna ignore it. The total cost for writing it into 1 big string is n times m. So the total cost of the encode function is the cost of running the generator plus the cost of running the join. So it's O of nm plus O of nm. So the total cost of the encode is O of n times m. So for decode, this might be a bit easier to understand because the code is a lot less dense. Decoded, defining a variable is O1, this is O1 as well, defining a variable, it's not worth considering. And then let's have a look at what happens here. So the cost of finding an index is gonna cost O of 3 because we have to read through at most 3 digits before we hit our delimiter. It doesn't matter if you're looking for this delimiter or this delimiter. So if my I is 0, then it's gonna find a delimiter from the beginning. But if I pass I as like something that's like 7, like let's say I is here, then the index function will actually first jump here and then it'll scan the rest of this. So it won't scan like this part again. So it'll only scan this part. So at most, no matter what, no matter how many delimiters that we've found, we only have to read up to 3 characters before we hit the delimiter. So that's why I'm saying the cost of running index here with this I is gonna be O of 3 in the worst case. And then the length, likewise, well, it's only gonna be 3 characters at most. So I'm just gonna put O of 3. And this step is just increasing the value by 1. We'll say this is O1. So far everything is in constant time. So let's have a look at this extraction part. So grabbing the element from, let's say, I is here, all the way to I plus length. This is going to be as long as a single string. And as we defined before, the length of an average string inside strs is m. So this is going to cost m. And then appending the element is O of 1, and just adding 2 integers together is O of 1. So we can see that in 1 iteration, the cost for 1 iteration is O of m. And then how many iterations are we running? We're running as many iterations as there are strings. So we're going to repeat this n times. So the total time complexity is m times n for both encode and decode. And that's the solution. Okay, bye.